although it's still technically about a month away because of fall break. And then the unit after that is also super short. So I mentioned before, we get 5-unit tests in semester 1, 3 in semester 2, but also in semester 2 is that state testing. So this is how we broke it up. Make sure that you are staying on top of all your things and not letting yourself fall behind, because these next couple of units are going to go by the quickest. And we're jumping right in today with 2-step inequalities. So inequalities, words that begin with the prefix in, like inappropriate, usually mean like the opposite. Like opposite of inappropriate would be appropriate. Opposite of inequalities would be equations, basically. Equations have equal signs, inequalities don't. Inequalities, you have 4 to pick from. And you will use an open circle to graph if you have a less than or greater than sign. You will use a closed circle in graphing your solution if it's less than or equal to or greater than or equal to. So these are your 4 possible inequality symbols. The first 2 are this less than, greater than. The second 2 have an equal sign in it, at least half of them. So any answers using this can be less than or equal to, and vice versa. Okay, now the graphing your solution is important. I don't necessarily think you're going to be tested on graphing like a normal inequality. You'll be tested on graphing like your linear inequality, where there's shading involved and all that good stuff. But this is still important in understanding that this time your answers are not just one number that makes it true. It's like a range of numbers that may be true. So like x less than 3. If I'm graphing it on a number line, the solution, first of all, it'd have to be where the x is isolated, and it already is. So this would be like a solution. Whatever number it's being compared to would be where the circle goes. And class, based on this symbol, should it be open or closed? Open. That's where you look up here for that. All right, open circle. And then you need to draw an arrow that shows where the numbers are less than 3. So think about it, look at some of the numbers that are labeled. What direction should the arrow go to where it's pointing at numbers less than 3? To the left. So then from your open circle, draw an arrow pointing this way to show that x can be any of these numbers. And plug them in and see, is 0 less than 3? Yes, and I'm pointing my arrow the right way. Is 3 less than 3? No, that's why we had an open circle to show that 3 is not included in the solution. Questions so far? Do you think you guys could try the next 3 on your own? Go from that. Knowing where to put the circle. Some of you look panicked. Let's do one more. Let's do the x greater than or equal to 7. So what number needs my circle? 7. Will it be open or closed this time? Closed. Closed because it has that equal to part. That means like if it's 7 exactly, that's included in my solution set. Because 7 is greater or equal to 7. But what direction should I draw the arrow to where it's pointing at numbers that are greater than 7? Left or right? To the right. 8 is greater than or equal to 7, and so on. So remember that the opening should be facing the bigger number. even if I were to rewrite it backwards, maybe like this, 7 less than or equal to x, it would still have the same graph because x is still the bigger number in this situation. So like your alligator mouth wants to, that's what's important. So now try those two, maybe even try the ones underneath it. We'll go over these in about 1 minute. All right, so once the x is isolated and then these are already, then graphing them goes according to what number it's being compared to. That's what your circle should be on. For this one, it should be an open circle because -1 is not greater than -1. It doesn't have that little equal to part in there. And it should point at the numbers that are greater than -1. Okay. The other one I had you try, this one, you should have a closed circle on the -5. And the arrow should point to numbers that are smaller than -5. So to the left. Good. Any questions? Okay. So then moving on, these are also good things like working backwards. But like I said before, these are a little too easy than what's going to be on your test. So we're going to keep going. But if you did have the inequality graph for you on the number line, pick a variable, compare it to the number that the circle is on. And since that's an open circle, my options are either that one or this one. And the one I picked should make it true. So it looks like we're pointing at numbers that are smaller than -2. So x needs to be less than -2. Be able to plug in numbers for x and it make it true. All right, but moving on. We're going to actually solve them now. And the steps for solving inequalities are the same as solving equations. In another lesson, we'll write out those long steps, like the distribute first is necessary, combine like terms with necessary, all that stuff. But today we're just going to look at 2 steps. So when you are solving inequalities, if you want to include this, I would put is the same as solving equations. You still want to isolate the variable, but it's the same as solving equations, except for when you flip the symbol. All right, so solving inequalities is the same as solving equations, except for when to flip the symbol. Otherwise, you still do operations on both sides of the symbol, whatever needs to be done to undo something. You just now have to pay attention when you do something on both sides because sometimes you need to flip the symbol. And that's what we're going to write over here when you need to do that. So you must flip the inequality symbol when you, does anyone remember from middle school? When you multiply or divide by a negative number. So flip the inequality symbol when you multiply or divide a negative number. And I would even extend this to say on both sides of the inequality. Okay, the reason I specify that, just because you're multiplying a negative on one side, like maybe it's -3x plus 2, That's not why you flip it. You only flip it when you're having to divide it on both sides to cancel out something. Okay. Otherwise, you just copy it over exactly like you would an equal sign. Questions on that rule? All right, we'll see it in action in a minute. All right, but let's look at number 9. So same thing as when you're solving an equation. Always get rid of what is furthest from the variable. So class, what's farther from the x, the 3 or the 2? The 2 is technically farther. 3 is right up against it, so we have to get rid of that last. How would I cancel out this 2? And whatever you do on one side of the equal sign normally, but now it's an inequality. Whatever you do on one side of the symbol, you good. So I get 3x on the left. And anytime you do something on both sides, just check to see. Did I just multiply or divide a negative right now? So then don't switch the sign. All I did was subtract. You never switch the sign. Okay. -4 minus 2 is what? -6. And keep isolating x. So look at what's being done to it and then do the opposite. Table 8, what's the opposite of multiplying by 3? So we're going to do that on both sides. It cancels out the 3 on the left. Class, do I need to switch the sign when I do that? Did I multiply or divide a negative on both sides? I did not. I divided a positive on both sides. So don't flip the sign. And that's where I made sure to emphasize. When you're multiplying or dividing a negative on both sides. Just because this 6 is negative, that doesn't mean you flip the sign. It has to be what you're dividing by on each side. Be negative for it to flip. Okay, so otherwise, what is -6 divided by 3? And now that I have the x isolated, this is my solution. X less than -2. Any value that is smaller than -2 will make this true. To graph it, notice that this one's blank. That's fine. Make sure that your number line includes whatever x is being compared to. So usually I would put that in the middle. And to the right on the number line, the numbers should get bigger or smaller. Bigger, so like this one would be -1, this one would be 0, then 1. And to the left, they should get smaller. So like what would this number have to be? Okay. All right, table 9, open or close circle on the -2. Open. And table 1, what direction should it go? Left or right? Left, because that would be numbers that are smaller than -2. Good, any questions? We're gonna go to the back next. So if you're a slow note taker, jot it down. We're gonna do another one together before I have you try to remember. Okay, so we are going to look at number 12. So looking at 12, 1, because I want you to be better with the fractions, and 2, I want you to see when a sign might flip. So same concept, look at what's going on with the x and get rid of what is farthest from it. So table 2, in this one, would I need to get rid of the -8 or the -5 first? Good, and how would I cancel it out? So we're gonna first add 5 to both sides to make this -5 cancel. Everyone visit. So I get x over -8. Class, do I need to flip the sign when I add? No, then just copy it over. We're not flipping the sign ever moving out of it. But. And then what's -2 plus 5? Now continue isolating the x. Table 3, what would I have to do next to isolate it? How would I undo dividing by -8? So that's what I'm going to do. I'm going to multiply both sides by -8. Do on one side, do the other. If you ever want to make something not a fraction anymore, multiply it by the denominator. You'll see that all throughout this year. All right, but that gets the x alone. Class, do I need to flip the sign? Because perfect. So maybe highlight that, star it. Me multiplying a negative on both sides is going to change direction to the inequality. So instead of less than, it's now going to be greater than, and then what's 3 times -8? -24. Now that's my solution. Good. All right, when graphed, I want to make sure my number line includes this number. To the right of my number line should be numbers that are bigger, and to the left should be numbers that are smaller. I'm not necessarily waving them into a tick mark. Table 4, open or close circle on the -24. And table 5, should the arrow go left or right? Sorry, over there. That would be numbers bigger than. I'm going to give you guys a couple to try. It's going to be number 15 and number 20. All right, I know those have fractions in them, but you've seen them before. Those with an equal sign. So the only thing that's different now is sometimes you have to flip the symbol. And that only happens in certain situations. We read it on the front to see what it is. So try 15 and 20. I'll project them in about 5 minutes. If you have a question, make sure you tell me. Number 15, when solved correctly, your final answer would have been x greater than 8. 8 less than x would be the same thing, although I wouldn't imagine you moved the variable. You wouldn't have needed to. But here's how I did it. You had to get rid of the 5 curves. You don't have an option there. You always have to get rid of what's farther from the x. And do what you need to do to make it cancel. If I subtracted 5, make that 5 go away. Whatever you go on one side, you put it together. You never have to worry about flipping the sign when you subtract, but just anytime you're doing things on both sides of the symbol, just check. Did I do one of those 2 things that make me flip the sign? Okay. Now over here, you could have phrased this 2 different ways. I multiplied by the reciprocal to cancel out the coefficient. So I multiplied by 4/3 on each side. You could have also said you divided 3/4 on each side. That's the same thing. Only thing with that is I think it does get tricky. Like I feel like you need to use a calculator to get the right answer if you do that. So we could have either multiplied 4/3 on each side or divided 3/4 on each side. That's a positive number, so I don't need to flip the sign. And when I multiply this, 6 times 4 is 24. 24 divided by 3 is 8. But again, we can use the calculator. Any questions on that? I didn't graph it this time, but hopefully you know how to graph it if you need to. Scrolling down, let's look at 20. All right, in this one, you had to get rid of the -2 first. That is technically farther than the 11, but it's set up like this. The 11 is on the same side of the fraction, so that's technically closer to the x than the -2. And then do the opposite. Instead of dividing the -2 or multiplying it, wherever you go on one side, do to the other side. Notice that multiplying the negative is one of those two things we wrote on the front of our paper that needs to make the sign flip. So at this stage, it should be x plus 11 greater than 4 because of that sign flip. And remember, if you ever want to break up a fraction, multiply by the denominator. Now it's no longer a fraction. And then it becomes really easy from here. Just subtract 11 on both sides, and x greater than -7. It has to face this way. Move your answer. Questions, comments, concerns? Okay. Your practice, the other paper you picked up, is just going to be evens or odds. Evens or odds. So do them. You will have to upload it to Schoology when you are finished. I will be able to check it tomorrow. So if you want points for it, upload it. Evens or odds. Any questions? That's all I have for you.